We have to leave. They're terminating Java.
With the increasing controversies surrounding its security, Java is under fire again.
It's supposed to write once, run everywhere. But it's more like write once, ruin everything.
Using compilers.
That's enough because I don't have a lot of time. But you can find it. It's on the JavaZone conference. They are producing amazing amount of videos like this. The second freedom is, of course, to study how the program works, and that means you need to have access to the source code. The third one, or the freedom number 2, is to give away copies of the software to everyone. So if you have software to give away, let me know, I'll take it. And the third freedom, or the last one, is to be able to distribute copies of the changes you do. So you take my software that's really crappy, you do something good with it, and you have the ability and the freedom to distribute it to other people. Whatever you get paid for that or not, this is something like a different topic. All right, so what is the next slide? Okay, so if you don't know how to get started using open source, contributing to open source free software, there's a really nice website called upforgrabs.net. There are currently more than 1,000 needs for help. If you're not a programmer, don't worry, you can do a QA, you can do copy changes, you can do testing, you can do design, you can do marketing or HR for those projects, everything, starting from the project that you never heard about before to projects like WordPress, Fedora, Mozilla, and more. So yeah, we have. We talk about creation, fix the problem with inspiring others, sharing. Hey, this is what I do for fun. Really join me next time. Through contributing to the open source, which actually gives you a lot of freedom. And if you're really, really, really bored at work, and this is my example, don't tell my boss, sometimes I go and contribute to open source software. And they're really amazing projects that you can start contributing to right now. Can we have a show of hands who is contributing to open source software or free software? Okay, for those that didn't raise your hand, you can start doing that. It's easy and it's worth it, and you can earn some money as well. All right, so the third way of how you can bring back fun to your work is to address the problem of I don't have a lot of time. I'm sure, and I'm really thankful that there are just a few people that are looking at their phones right now. And I know that this is not usually the way on conferences like that, or in the public transportation, or in your life. You're just like, hey, what's going on? Oh yeah, someone beat me. Ooh, Madonna naked. Ooh, let's go. Okay. And we as a community and as a humanity, we spend too much time on this little device. And every day we are looking at disinformation, we're looking at bad news. And guys, to be honest, there is no antivirus software of the disinformation that you're looking at every day. It goes directly straight to your brain, through your eyes, stays there, forms your brain waves in the way how you think, and there is nothing you can do about that. So I'll say, let's do this. Let's do it. By the way, that is not my phone. During the coffee outside, I stole it from someone. I really hope he is not in this room. All right, I know that I don't have time. Before I go, there is a pub quiz today at 4:15 in the basement downstairs. There is a D3 cell. So there'll be 16 questions about how well you know open source, free software, OpenFast, and some other topics that I'll keep secret. And you will get a lot of prizes. If you win as a team winner, you need to have fun with other people, so we'll form a team. And useless box, 2 complex, 2 times useless box, and a lot of amazing other awards await for you together with the fun. So if you want to join, downstairs in the D3, so you'll see us there. And I credit Review.js for this amazing slideshow, Audacity for the sound mixing that you heard from time to time, and for the evil laugh that you heard from Skynet voice is thanks to the freesounds.org, which is a great website to start doing something. Thank you for your time today. If you scan this, I didn't want to put it because it's a security violation, but the team, they make me do it. So if you want to give a feedback for this talk, you can do it here or in the link there. And can I get a round of applause for those guys over there that are doing an amazing job? Thank you guys. They stayed all night last night to make sure that everything here is as it should be, and all of the volunteers. Thank you, and if you have a question or if you want to talk to me about, if you want to buy me a beer after 11 o'clock, I'm here all day and tomorrow. Thank you.
Много ти благодарим, че беше нашия така, много ни забавлява. Хора, сега 10 минути почивка и след това ще се видим отново тук. Искам само да ви кажа, че има лека промяна в програмата. Следващата лекция в зала Б ще я има, но лекцията след това просто лектора е възпрепятстван да дойде, така че няма да се осъществи. Секунда.
Personal Linux. Susan, hear your prayers. Susan.
What we say within our company is working for your productivity. Zeus of the cloud, Zeus of the core. Dare to be different, dare to be more. I see my friends go party to proprietary code. I have to shake my head as their frustration grows.
Just silver money, information highway. Look into the future, and it could be the next MySpace. Yeah, people, we can make it happen. Take the world to a greener place. We're just needing to know the standard. Zeus is leading the way.
A software development company, and what we're doing is end-to-end software development.
Place for you to grow, not only as an IT professional, but also as a great human being.
Hacksoft is a game-changing player.
Hacksoft is family.
Cringe. Idol.
Personal Linux. Susan, hear your prayers. Susan's there.
What we say within our company is working for your productivity. Zeus of the cloud, Zeus of the core. Dare to be different, dare to be more. I see my friends go partake to proprietary code. I have to shake my head as their frustration grows.
Just to the running. Information highway. Look into the future. And it could be the next MySpace. Yeah, people, we can make it happen. Take the world to a greener place. We're just needing to know the standard. Zeus is leading the way.
Добре работи.
A software development company, and what we're doing is end-to-end software development.
Place where you can grow, not only as an IT professional, but also as a great human being.
Hacksoft is a game-changing player.
Hacksoft is family.
Cringe. Idol.
Personal Linux. Susan, hear your prayers. Susan's there.
What we say within our company is working for your productivity. Zeus of the cloud, Zeus of the core. Dare to be different, dare to be more. I see my friends go partake to proprietary code. I have to shake my head as their frustration grows.
Just to the running. Information highway. Look into the future. And it could be the next MySpace. Yeah, people, we can make it happen. Take the world to a greener place. We're just needing to know the standard. Zeus is leading the way.
Добре работи.
a software development company, and what we're doing is end-to-end software development.
Place for you to grow, not only as an IT professional, but also as a great human being.
Hacksoft is a game-changing player.
Hacksoft is family.
Cringe. Idol.
Personal limits. Sincerely hear your prayers. Sincerely's there.
What we say within our company is working for your productivity. Zeus of the cloud, Zeus of the core. Dare to be different, dare to be more. I see my friends go party to proprietary code. I have to shake my head as their frustration grows.
Get yourself a running. Information highway. Look into the future, and it could be the next MySpace. Yeah, people, we can make it happen. Take the world to a greener place. We're just needing to know it's time to Zeus is leading the way.
Добре робить.
A software development company, and what we're doing is end-to-end software development.
Place for you to grow, not only as an IT professional, but also as a great human being.
Hacksoft is a game-changing player.
Hacksoft is family.
Cringe. Idol.
Personal limits. Sincerely hear your prayers. Sincerely's there.
What we say within our company is working for your productivity. Zeus of the cloud, Zeus of the core. Dare to be different, dare to be more. I see my friends go party to proprietary code. I have to shake my head as their frustration grows.
Get yourself a running. Information highway. Look into the future, and it could be the next MySpace. Yeah, people, we can make it happen. Take the world to a greener place. We're just needing to know it's time to Zeus is leading the way.
company, and what we're doing is end-to-end software development.
A place where you can grow, not only as an IT professional, but also as a great human being.
Hacksoft is a game-changing player.
Hacksoft is family.
Cringe. Aí.
Personal Linux. Susan, hear your prayers. Susan's there.
What we say within our company is working for your productivity. Zeus of the cloud, Zeus of the core. Dare to be different, dare to be more. I see my friends go party to proprietary code. I have to shake my head as their frustration grows.
Get yourself running. Information highway. Look into the future, and it could be the next MySpace. Yeah, people, we can make it happen. Take the world to a greener place. We're just needing to know the standard. Zeus is leading the way.
Добре работи.
A software development company, and what we're doing is end-to-end software development.
A place where you can grow, not only as an IT professional, but also as a great human being.
Hacksoft is a game-changing player.
Hacksoft is family.
Cringe. Aí.
Can you? Oh, great, amazing. Hello again. We are ready to continue with our next talk. I'm very happy and excited to introduce you Drew Gallatin, who is here on the stage with me at the moment. Drew has been working for Netflix for eight years, maybe something like that. Yes, and his specialty is FreeBSD kernel optimizations, and he's been committing to the FreeBSD for more than 25 years. So let's give Drew a round of applause and welcome him on the stage, and let's hear more about the magical mystery merge.
Hey, so I'm here to talk a little bit about, first about how we use FreeBSD at Netflix, and then to talk about why we run FreeBSD current, and to give a nice little case study, which I call the magical mystery merge, which kind of exemplifies why it's good to run current. So I work on our CDN, And a CDN is basically a content distribution network. A lot of companies use that to distribute, operating system updates or video games or movies like to their customers all over the world. We call our CDN Open Connect, and we call our CDN servers Open Connect appliances. And we call them appliances mostly because in a lot of ways they have a little bit more in common with like your home router than they do with the server at your office. And what I mean by that is we have like an A-B partition, and we re-image them every time we update them. So we image the B side, and then if that fails, it falls back to the A side. The software is completely identical on every single machine. There's no package on some machine that's not on other machines. This is an example of one of our OCAs that can serve 400 gigabits a second. We currently have 3 different types of OCAs. We have a all-flash OCA, meaning all NVMe, or the older ones are all SATA SSDs. They serve the very most popular content, and those are mostly located in our data centers at interchange points where the internet comes together. We also have storage OCAs, which hold hundreds of terabytes of video assets, and that could be anything from a really unpopular title that somebody only watches once a week to even the very most popular things. And we also have what we call a global OCA, which is given to smaller ISPs to help them offload the traffic that's coming to their network. So for example, if you're watching a movie, it's coming from inside your ISP's network and their uplink isn't affected by that traffic. So a little bit about the OCAs. We run FreeBSD current, and I'll get into why we run current. And one of the most frequent questions I get asked is, do you run ZFS? And yes, we do run ZFS, but we only run it for root. We don't run it for our content partitions. And that's because ZFS has its own cache called the ARC, or the Adaptive Replacement Cache, which is separate from the kernel page cache, which means in order to serve anything out of ZFS, things need to be copied from the ARC to the page cache, which is inefficient. So we run UFS for all of our content partitions. We run Nginx as our web server, and the other thing I wanted to mention about our file systems and stuff is that unlike a lot of CDNs, we just let drives fail in place. We don't run any RAID. There's no redundancy except for the root partitions. But for the content partitions, we just let drives fail in place. It's a lot easier to just let it fail in place than to try to get ISPs to replace a drive or to send technicians to data centers. And the machines they mostly have so much storage that they lose 1 or 2 drives. They're still very useful as they are. So our workload is basically serving static files. Everything is pre-encoded before it even hits our CDN. So we have, if you're watching a video, there'll be a different codec for maybe what's on your phone versus what's on your smart TV versus what's on your computer. And there'll be all the different bit rates. So like one particular TV show or movie could have dozens of different downloadables for it. And we do this because video quality is like of the utmost importance, and we spend a lot of time and effort on making each encoding as good as it can possibly be. And so the nice thing is that having everything static simplifies our workload since there's no compute involved on the CDN server. And so a little bit about FreeBSD. I think most people here are familiar with Linux. FreeBSD got its start around the same time that Linux did, but in a much different way. Whereas Linux was written from scratch, FreeBSD is directly descended from the BSDs that were the basis of Sun OS and things like that in the 80s. FreeBSD came out of 386 BSD, which was a port of the old BSD to x86, 386 boxes. That 386 kind of fell into a little bit of disrepair, and there was a patch kit that was maintained, and there were 2 groups of people that were maintaining the patch kit that sort of forked. NetBSD came out at roughly the same time. They focused on compatibility and correctness and running on as many architectures as they could, whereas FreeBSD focused on just performance on, at the time, x86 32-bit. Our first 64-bit port was in the late 90s. That's how I actually got my start as a FreeBSD committer. I worked on that port. But FreeBSD likes to basically really support the current high-performance architectures. And so once an architecture is sunsetted by the vendor, we sunset it as well. So the Alpha port was the first port we ever retired because, sadly, Alpha died. So FreeBSD is a little bit different than a Linux distro because in Linux everything is packaged. In FreeBSD, we still have this legacy thing where we have the kernel and all of the basic utilities, like you would expect on a shell, like the actual shell itself, like ls, move, copy, that kind of thing. The compilers, all that stuff is unpackaged and belongs in the root file system. And we also package, we also believe in packaging third-party software. Things like the Firefox web browser or the Nginx web server or things like that come in packages. And so when you install FreeBSD, you get all that, plus all the source and the man pages and documentation. At Netflix, we have our own stripped-down distribution that we run on our OCAs, and that obviously doesn't include compilers or documentation or most packages, just because we don't need those things. And so the team I work on at Netflix is called the OCA Dev Team, and our responsibility is to maintain the software that runs on the OCAs. Most of us are FreeBSD committers or contributors. There's roughly 10 of us, and it's a great place to work, and it's the best job I've ever had. So I want to talk a little bit about how we do FreeBSD development at Netflix. When we first started off, we made the choice that everybody makes, which was to track a stable branch. And to back up a little bit, the way FreeBSD works is, in some ways, if you're familiar with Linux, it's similar to Linux. There is what we call FreeBSD current, which in many ways is similar to like the Linux tree, where everything goes in there first. And then there are stable branches, which are what in Linux most people call long-term support or LTS branches. And so in FreeBSD, there's a new release, supposedly every 2 years. It really works out in practice to be every 3 or 4. And so every time there's a new release, a new long-term support or stable branch is created. And so what we used to do is we used to track the latest stable branch, and then every few weeks we would merge all the security fixes and bug fixes that made it into the stable branch. And we would then make an internal release that would go out to our OCAs. And that worked really well for the period we were doing that. But what was terrible was when we moved from one stable branch to another. And that would take sometimes, in the best case, weeks. Most times it would take months, up to 6 months, because you could encounter a problem, either in code that we never managed to upstream, being compatible with the new interfaces in the new version, or there could be some kind of regression introduced upstream in the new version that was hard to track down. And so these merges, every time we updated between stable branches, were just awful. And when we ran stable, it was also very hard for us to collaborate with upstream, because the stable branches, the APIs might be different. Like some function might take 3 arguments in stable and 4 arguments in current or something like that. And so if we wanted to contribute some change we made, we would first have to port it to current, then somehow test it because we weren't running current on our machines, and then submit it for review, get it accepted, and then it would finally be there when we went and moved to the next branch. And so there's very little motivation to do it, which meant we were keeping a lot of things back, which made each successive merge harder because we would run into more and more conflicts the more and more stuff we had. So we could see that we were kind of building up a technical debt by doing this. And so about 5-6 years ago, we decided what we were doing was silly, and what we should do really is to track FreeBSD current. And that sounds crazy on the face of it because that's where everybody pushes all their stuff. And unlike Linux, there's no subsystem maintainers. In FreeBSD, when you have a commit bit, you're allowed to commit, whatever you want. You're encouraged to get reviews, but it's treated with freedom and responsibility. But at any rate, current is sometimes somewhat unstable, and so running current sounds crazy, but it's actually the best thing in the world, because when we run current, we do the same every 3-4 weeks merge cycle, where we pull in the stuff from upstream, and when we do that, we catch things really fast. If there's some regression, we catch it right away. There's no 2 or 3 year delay between somebody committing something and us finding it's a problem. And it also allows us to upstream things much more quickly because we no longer have to port it to basically a different version of the operating system. So it allows us to collaborate with upstream developers and get our changes in to FreeBSD quickly. And over the years, the amount of things we've held back has decreased and decreased and decreased. So speaking of upstreaming code to FreeBSD, basically, since we run current, our tree is almost identical to the upstream FreeBSD tree. And so if we want to make a small feature or if we want to make a small bug fix, what we often do is rather than doing it in our tree, we actually do it in the actual FreeBSD tree itself, get it reviewed and committed, and then that will just naturally come back in our every 3-week merge cycle. So that greatly reduces the amount of technical debt we accumulate by keeping our own patches. And if there's something critical like a security fix or a bug fix for a crashing issue or something, we'll cherry pick it immediately rather than waiting for the merge cycle. But for larger changes, like when we did kernel TLS, that was a very large, very invasive change. And so we kept that to ourselves for close to 5 years. Not because we were trying to be secret or proprietary, but just because we wanted to get it in the form that it actually needed to be in to be useful upstream and not just to us. So we do testing. Every time we push to a branch, the Jenkins job it gets kicked off. At Netflix, we run on both AMD 64, which Microsoft also calls it AMD 64. Everybody else calls it x86 64, and ARM 64. And so we run a small regression suite on that. And then every night, or close to every night, we run what we call a smoke test, where we run with all debugging enabled on the kernels, meaning like memory corruption checking, use after free checking, lock reversal, lock ordering checking, all the checking we can check is running close to every night on a small cluster of machines, looking for any bugs that we've introduced. And then when we do release testing, we run it on a slightly wider set of machines at with all the bug checks off, just looking for any performance differences or any other regressions that we can find. So we've contributed a lot to FreeBSD over the years, which I'm very proud of. Probably the most important, most fundamental thing we've contributed is something we call async send file. That was done by my colleague Gleb Smirnov in collaboration with Nginx. And the gist of that is that when send file is a system call which basically says if you have a file here and a socket there, you don't have to read from the file into user space and then push things back into the kernel. It tells the kernel, take data from this file and put it on this socket. And the problem with send file in most operating systems is that it blocks, because you have to wait for the stuff to come in from disk. And so asynchronous send file basically allows the web server to just say, do this send file, and then return immediately. And then the operating system in the background brings the data in, and then the interrupt completion handler for the disk drive then pushes things out to the network. And that allows us to avoid having thread pools or using async IO or doing any sort of thing like that. And that one thing is the fundamental optimization that's enabled everything else. Something else we do is what we call unmapped mbuffs, and that was done to prepare for kernel TLS. Basically, mbuffs are the fundamental network buffer in FreeBSD, and unmapped mbuffs essentially it's very much like a Linux SKB frag structure, where rather than pointing to one data object, they can point to many data objects. And so one single mbuff can carry an entire TLS record with 4 4K pages or 5 4K pages, and header and TLS signature information. And that is just by itself, even without TLS, is a big optimization because it saves a lot of cache misses when you're doing pointer chasing and things like socket buffers. There's kernel TLS, which basically moves bulk data encryption from OpenSSL and user space to the kernel. And the reason why that's valuable is it, again, avoids doing lots of boundary crossing, because without kernel TLS, you need to read data from the file into your user space application, do the crypto, then push it back into the kernel. This allows you to avoid that detour, do the crypto in the kernel, and have things go right out. And even better, if you have a network card like a Mellanox ConnectX 6DX or newer, or a Chelsea OT6. Then you can do kernel TLS, actually NIC TLS offload, which lets the NIC itself do the encryption, so it makes it essentially from the kernel's perspective like there's no crypto at all. Stuff just comes in from storage, goes out on the network. Kernel never even touches the memory. That's why the MBUFs are unmapped. We've also contributed something we call the CAM IO scheduler. CAM is the FreeBSD acronym for its storage system. And the idea behind that is that we like to be able to fill from other OCAs content that's needed at a particular site at the same time we're serving traffic. And we found that a lot of storage devices, if you're doing a lot of writes, the read performance suffers. And so CAM, the IO scheduler, sort of mitigates the speed at which writes happen or reads happen in order to keep everything nice and smooth. We've contributed the rack and BBR TCP stacks. You may have heard of BBR. It was done by Google initially in Linux and ported to FreeBSD by my colleague Randall Stewart.